Okay, we're going to look at some more details about these polynomials now. And let's see. Okay, there's a few things about polynomials, some vocabulary that we're going to talk about now. Okay, vocabulary. Now, polynomials are made up of terms. And a term looks something like this. 3x squared or 5xy or 7 or let's say 4x. Those are terms. Now terms, and these are also examples of polynomials, each one of them. What they're called, in this case, these are called monomials because there's only one term in each of them. Okay, one term in each of these. Now notice you can have more than one variable in a monomial term. Okay, so these are all monomials are examples of polynomials, but they only have one term. Now in each of these, there's some more detail about these. The coefficients are the numbers up in front, those constants. Coefficient 3, 5, 7 is its own coefficient, and 4, those are coefficients. Okay. Now, the degree of a term, okay, degree of a term, polynomial term, in this case, a monomial term, is the sum of exponents of the variable. Okay, get a little ahead of myself there. Is sum of exponent variables, exponents on the variables of the variables. That's by definition, that's what it's called. So, for example, that first term has degree. I'll just come down this way. Let's list our degrees that we have here. We have a degree 2. The second one also has degree 2 because 1 and 1 makes a 2. This third one actually has degree 0. There is no variable, so we say that's degree 0. And this fourth term has a degree 1. Okay, so now we also have the concept of the degree of a polynomial in general. Okay. Now, because polynomials come in different sizes, and you might have a polynomial with more than one term. So the degree of a polynomial comes from, it's the same as the term degree that is the highest. Okay, so for example, we might have a polynomial that looks like this: 3x squared y minus 4xy to the third plus 7xy to the fourth plus 4xy and then maybe plus 7. This is called a constant term. Okay, so to figure out the degree of this, you have to look at each term and figure out the degree of each. So mentally you can do this, or you can just write it down. Degree of each. This one would be a 3. This would be a 4. This would be a 5. This would be a 2, and this would be a 0. So since this one is the highest of all, it determines the degree of the polynomial in general. So what we have, whoops, I get to, it's my scribbling there, I'm gonna get rid of that. All right, so now, so that means the degree, this is the degree of each, okay, that we did here. So the degree of the whole thing, the whole polynomial, the entire polynomial is 5. Okay, so that's how we determine degree of terms and the degree of polynomial itself. Now, we know that we can also talk about some different kinds of polynomials. Of course, we know what the monomial is. That's one term. Okay, one term. And we saw examples first. Binomial also comes up often enough. That's 2 terms. So examples of binomials would be like 3x plus 5, or 7x squared minus x, or 1 plus x to the third. For example, those are 3 examples of binomials. Okay, and a trinomial, I think you can guess what that would be. Trinomial, that has 3 terms. So you might have an x squared plus 2x plus 1, or an xy to the third plus x plus 7. 3 terms. So there's a couple examples of a 3-term polynomial. Anything higher than that, we don't really have a special name for. We call it a multinomial if you want. Okay, so that's a little vocabulary there. Now, we're going to look at some addition and subtraction of these polynomials. So let's look at an example. If you were in the middle of an equation solving, which you have done in the past, and you encountered something like this, like 5x plus 2 minus 3x plus 7, and maybe that was on one side of the equation, and you had to tidy it up, so you would just add, let's say that was 7x. You would look at your 5x and your 7x, and those are known as like terms because they have the same exact variable. Okay, and you distinguish those from these numbers in the middle, which had no variable. So I think most students are fine with just accepting that and stopping here. So these are now unlike terms and can't be combined any further. Now, the same thing holds when we have terms with higher degrees. For example, if I have 5x squared plus 2x minus 3x squared plus 7x minus 2, for example. Well, I identify my like terms first. This term matches this term. Okay, so I'll put those together. That's 5 minus 3 is 2x squared. And then I might go and put these two together. That term matches that one because those have the same variable x to the first. So that makes a 9x. Notice how I add them. I do not change the variables. This is x squared, this is x squared. That becomes 2x squared. 2x, 7x makes 9x. Do not change the variables. Don't change those exponents. And then finally, we can write that minus 2 down there because it's sort of the oddball and doesn't have a match. And that would be our answer. Leave it like that. And incidentally, this is considered standard form. Okay, standard form is when you start and order your exponents from highest to lowest. We would say descending order, okay, for those powers, descending powers, right? So that's how we combine like terms. Now, it's not going to be any different if you have polynomials to add together. So for example, if I have a 5x squared minus 3x plus 7, and somebody said, okay, you want to add that to this other polynomial. Let's say it's a 3x squared plus 4x minus 5. I'm going to add these together. Well, it's just a whole bunch of like terms and unlike terms. I'm going to combine like terms. So I'm going to have 8x squared, and I have a negative 3x, and 4x makes a plus 1x, and then the 7 minus 5 is a plus 2, and it's done. Okay, we've just added two polynomials, this one and this one. It's nothing more than combining like terms. Okay, now sometimes things get a little bit more difficult if you have more than one variable. For example, if I have 5x squared y plus 7xy plus 3xy squared minus 7yx, we'll make it plus 7, and then plus 2x squared y. Okay. Now I'm going to try to combine these terms. Okay, so this is one polynomial with a whole bunch of terms, and I want to simplify. Well, you have to look at matching terms, like terms. Okay, I look here and I see the only one that matches this is this guy here in the end. Okay, so notice that this middle term does not match. This one here does not match these others. This is unlike. Looks almost the same, but it's not, because the variables are, the exponents on those variables are not quite right. This one's x y squared, and this is x squared y. That makes it different. So we cannot add those together, but we can add the blue ones. Okay, the blue ones become 7x squared y. All right, now another thing that sometimes comes up when you're working is this situation. You have 7xy and 7yx. You have to realize that those are the same. Even though this says x times y and this says y times x, mathematically they're the same because of our commutative property. So that is really the same as 14xy. Okay. And then finally you have this term in the middle that doesn't really have a mate. So it doesn't match with anything. You just copy it down and then you're finished. Okay, so let's do a couple more of these. Let's try this one. 4x squared minus 2x minus 7. I'm going to minus 5x squared plus 4x minus 3. So I have two trinomials, subtracting the second one from the first one here. Now that means as it was subtraction with numbers, for instance, if you had 5 minus a negative 4, you would change it to addition of the opposite. We're going to do that here with the polynomial too. We're going to say this will be 4x squared minus 2x minus a 7. I'm going to change that to plus, but I'm going to change all these to the opposite signs, each one. So this is a negative 5x squared and a minus 4x and a plus 3. Okay, so I'm adding. Now I don't want to write extra addition signs like that. So typically I would not write an addition sign. I would just use the sign of my changed polynomial term and use that as my operation sign. So I would write it like this. Okay, so I would omit these extra plus signs in here and just go with the sign as your operation. And you don't lose any credit or any credibility for that. It's all legitimate. Okay, now we're ready to combine like terms. So I have a 4x squared and a negative 5x squared. That makes negative 1x squared. And I don't write the 1. Don't write it, just make it negative. It's understood it's a 1. Then, let's see, I have a negative 2x and negative 4x. Let's make negative 6x. And I have minus 7 plus 3 is minus 4. And that's finished. Okay, and if you double check your work, I'm going in kind of a hurry here. I want to get through a few problems and make this short. We'll do one more. Let's say we have a 4x squared plus 7 minus 8 plus 3x squared minus 2 plus x minus 5x squared. Okay, so we got a triple problem here. All right, notice these negatives, these minus signs in front of these groups. First thing you'll do is you'll drop these parentheses because they don't serve any function at all. Okay, except to group that as a polynomial. Now here you're going to drop the minus, or drop the parentheses, and change all the signs inside. So we have a minus 8, minus 3x squared. Over here, do the same thing. We have minus 2, minus x, and a plus 5x squared. So I'm taking opposite sides. Now I scan across and look for like terms. I say I have a 9x squared. Takes care of that and that. Whoops, I forgot my minus 3. Okay, so I'll go back. I'll fix that. Oops. Oh, I should have just erased that. Okay, but anyway, I'm going to do this term, and this term. So I got 4 minus 3 is 1, plus 5 is a 6x squared. That takes care of those. Okay, now I have, looks like I have I have a 7 minus 8 and a minus 2, but I'm going to do the x first. I'll just write that as a minus x, because now I'm in descending powers here. Then I'll take care of the 7 minus 8 is negative 1, minus 2 is negative 3. And that's good enough right there. Notice it's in standard form. We have descending powers. Okay. Descending powers, standard form. Okay. Start writing in standard form. It'll make your life easier. Easier to organize your information. Okay, so that is about it for that. Good for now.